Yeah, it's pretty good. I think just the summer is hard because everyone's US now. It's okay, I'll probably just go
Check, check, check. 1, 2, 1, 2. The Human Torch was denied a bank loan. Can you hear me? Can you hear me? I'm going to keep talking, still talking. I've got nothing to say. I'm still talking. Okay?
Is that going to be on the recording?
So, yeah, you could do an announcement. We're going to start in a minute. That's me, I think.
Yeah, yep.
That should go away too.
Okay. Is there a high number more?
It should disappear.
All right, everybody. We start in about a minute or so.
A little hot. I'm going to change the setting real quick. No, go here.
Okay, everybody, welcome. Welcome to Analyze Boulder. My name is Stephen. I'm your MC for tonight. Gargi can't be here. We have a great lineup of speakers tonight. First, we have to get through some of our opening material. Thank you to the organizers, Corbett Dean, Gargi is not here, Greg, I thank myself because I'm up on the page. Greg has been with us for quite some time and is going to be leaving the organizational team shortly. So if any of you are interested in joining and helping us to organize this every month, please come up and talk to one of us. Corbett Dean's not here also, but Corbett, Greg, or me, come talk to us. I want to thank Galvanize for letting us use this space. We've been here for quite some time. This is a great location for us. We've got a Tribe Called Quest playing in the background.
Rookie mistake, my bad.
I hope you all of you who are legal, were able to get some beers. We do have a tip jar. That's how we pay for these beers. Tonight we're going to do a little experiment. I think what we'll do is if you are an R user and love using R, give us $5. And if you hate using R, $6. We are on all kinds of social media. We have a Twitter account, which will be tweeting some pictures from tonight's event. Instagram as well. We're on LinkedIn. We also have a Slack channel where lots of discussions happen during the week, including some job announcements that might not get announced here. And so, does anyone have anything to announce? Any sort of hackathon or conference, data science related workshops, anything like that? If you raise your hand, we will run a mic to you so you can announce it. Nobody, no hackathons? We have one.
So I've announced this before at this meetup, but so I'm the runner of the Julia Users group here, and so I thought I would give a plug for our next topic. So we're talking about probabilistic programming as our next meetup. In that room tomorrow. So you all know where it is. Feel free to stop by.
Sounds pretty cool. Anybody else? Okay. How about jobs? Anybody hiring? Anybody working for a company that's hiring? Let's start with. Oh.
Hey, it's Immersion. It's a little company that has an office in Broomfield for
Hi, my name is Estan Aline. I'm a director of software engineering at Transit System. We have a lovely office just a couple blocks away from here. Our products are leverage-driven products. They're data-packed with their analytics fast. So that's what I mentioned. Today, we're looking for mobile development. So if you are interested, check out transitzone.com for years. Apply. You can also find me on LinkedIn. Estan Aline. Is something in the future you're looking forward to listening?
Okay, anybody else? Greg has one.
Anybody else?
So I am leaving. I am working currently at AutoMox here in town. We are a cybersecurity startup, Series A, growing very fast, and we have a very aggressive hiring plan for the next 12 months. And we have a lot of engineering roles being filled. We just got a second data scientist on board. We'll have more of those in the future if I have anything to say about that. But we're going to be trying to get on board senior engineer, front-end, back-end, quality engineers, director of software engineering. We are hiring for product. I'm a product manager there as well. If you are interested in this, come talk to me. It's essentially a patch management solution that is cloud-based, OS agnostic. Nobody else is doing this, and we have a lot of good traction going on now. We have all the problems we should be having. If you are interested or know someone that's interested, come talk.
See you later.
Hi everyone, I'm Diana, and I work at Honey. I'm a data scientist there, and we help people save money online. We have a browser extension, an Android app, and we're entering financial services. We're hiring Android engineers, QA engineers. For my team, I'm hiring data scientists to work on a lending product. So please come find me after if you're interested. So whoever is looking for jobs, make sure they talk to all of these people.
Yeah, let's have everyone who announced a job, once all the talks are done, come up here in front of the screen, and that way anyone who is looking for a job can come find you easily and talk to you, okay, rather than have people announce who's looking for a job right now. Okay, so we have a couple of great talks tonight. We have Jordan Hagan, who's going to talk about recommendation engines. Diane Hale is going to talk about explainability in machine learning. And then Chris Kohler is going to talk about network analysis of political discourse with hashtags. So after that, we're going to have a little bit of an icebreaker to get some conversation starting. We have the room, I think, until 8 after the talks, so feel free to stick around and talk to people. If there are any more undergrads who need to take selfies with us for course credit, you can do that at that time. And with that, let's start with Jordan.
Howdy. As I said, my name is Jordan Hagan. I am a senior data scientist with Miner & Kosh, who is a consultancy. So we do kind of all kinds of work. Right now I've been working more in retail, and so that's why I've been doing recommenders. I will talk very fast and at an incredibly high level since it's only 5 minutes. So when you guys want to dig a little bit deeper into it, let me know in the Q&A and we can go more in depth. So my objective, we're going to go ahead and review our problem statement, and then we're going to kind of dig into recommenders, an entire recommender ecosystem. So kind of how we started approaching the problem, how we attacked some problems we ran into, and then kind of linking that all together in a pipeline. So I had to anonymize this. So we're going to pretend we have a food company called Fake Italian Food Company, who sells all kinds of Italian food across the United States. They would like to strengthen some of their marketing efforts with a recommender. So we kind of was trying to figure out, where do you start with a recommender? If you have explicit feedback, which is like a 5-star rating system, you can kind of see what people like and what they don't like and trend through that. We didn't have that at our fake pizza company. And so I found this paper, hopefully we'll send out slides so you guys can actually click that hyperlink, on trying to extract explicit feedback through implicit feedback. Implicit feedback being customer interactions with your product. So did they buy it? Did they favorite it on your website? Did they return it so we can infer that they didn't like it? Did they buy it multiple times in multiple different like sizes of pizza and kind of things along those lines? And so there's ways in customer interactions where you can figure out, oh, they probably 5-star like this versus 1-star like this. What this also allows us to do is put in some weights and biases that we might want as a company here at Fake Italian Pizza Company. And so we can weight recency, being what you looked at more recently. We can go ahead and say that's probably 5-star versus if you only ordered that pizza last year, but you ordered it 3 times, maybe you like it, but you haven't liked it in a while. So maybe like a 4-star rating kind of thing. If you care about trying to recommend out things that might bring your company profits, you can go ahead and weight items that they like that have higher margins to be a higher 5-star rating or things along those lines. And so there's just a different way in this system to kind of analytically go through and get out that explicit feedback from that system. Due to the size, this Fake Italian Pizza Company has 15 million customers annually, and an item catalog of about 8,000 different pizzas. And so it's pretty massive. And because of that size and the size of what inevitably would be our user item matrix, we started out with Spark's ML lib and Spark's just general infrastructure with clusters, worked really well with that. Just starting baseline, that collaborative filtering with ALS, it can be parallel. I struggle with that word so hard. It can be split up on multiple different clusters all at once, and because my recommendations are agnostic from your recommendations, it can do a bunch of those calculations across all those clusters and run pretty quickly. So our outcomes, it runs nicely on our nightly on GCP's Datapod clusters with pretty beefy workers. I think it's 15 workers or so on different clusters that are running through it. It takes about 2 hours to run. I actually optimized it earlier this month and haven't updated my slides, so now it's about 1 hour to run, which is pretty great. Side note there, in Spark's JDBC URL, you can go ahead and pass in a hyperparameter to enable batch write statements that is not natively in there, and it will speed up your process if you're writing out to a database your recommendations. And then we go ahead and get 20 customers, or 20 recommendations per customer out of that. But one of the problems we ran into is that the original data it was run on and trained on is over the last year. of customer item interactions. And because of that, there might be items that we offered that customers bought a year ago that we no longer have on the menu. We don't carry that pizza anymore. Romaine lettuce is having an E. coli outbreak and we don't want to recommend it out, things along those lines. And so in this step, we have to do an item-to-item recommender translation to take what we no longer have in stock and go ahead and grab that most similar item that we do have in stock and recommend that out instead. Our original MVP approach to this was TF-IDF and cosine similarity done on item descriptions. Because of just the nature of TF-IDF and that it cares a lot about term frequency, it doesn't pick up on contextual things that like fresh and crisp or steak and ribeye would be similar. And so it tends to like focus on words like mozzarella, where that we might not get as much out of that as we want to. So current implementation uses word2vec and word mover distance. While slower, certainly, than TF-IDF and cosine similarity, word embeddings is the way to go on that one. We have really short text descriptions, and so each word is really important in it, and so the term frequency wasn't terribly helpful. And word embeddings were really powerful because we had to find that kind of similarity within that. So our next steps here is now that we have a customer level recommendation system, all built on the cloud, so this all exists within GCP's network, and goes ahead and runs from starting at BigQuery, we grab all that user item information out, that then gets loaded nicely into Dataproc, run through ALS, that then gets written out to a Cloud SQL database, that then gets pulled into GCP's just VM, their cloud instances. And then on that is where I do kind of the heavy calculation with the word deck and word mover distance. But now that we have this all written out to a database, what do we do with it? And so, as you guys know, with recommenders, there's a million things to do. So one of the other things I've been working on is a marketing project to go ahead and grab propensities to shop in different items. So either their propensity to buy pizza within the next 45 days or their propensity to go ahead and buy a salad within the next 7 days. And then we say, all right, they have a high propensity. We should go ahead and show them pictures of pizzas they might like. And then maybe through that marketing campaign, we can ensure that they go ahead and they come in and they order some pizza with us. Also is just the traditional way of you log into their website and you get catered recommendations to you, right? That one's, we all know that from Amazon, that's pretty straightforward. Another way we've kind of been using it is hopefully to be released on apps, as they have a pizza app as a like border around the app of like items that you might like. So just kind of a tag that you can go ahead and filter by, recommended for you items, things along those lines. And so as is a surprise to no one here, recommenders are incredibly powerful and can be used in multiple different ways. And I talked really fast, but I'm happy to go into depth on further things that you guys might have.
So you run your recommender nightly. How much do your recommendations change from day to day?
Right, so it depends on your interaction and customers' interactions with your items, right? So if it's a high traffic website, which a lot of people like pizza, it turns out, so we get a lot of traffic, it can change. We were weighing the benefits. It didn't actually, because of the way we wrote the pipeline, it's actually not terribly that much of a cost difference to run it nightly versus weekly. And so we're like, yeah, if we can get kind of updated recommendations where like you log in on a different day, and now you have new recommendations that might be a better customer experience. And so it might be something that if I can get them, I would actually be interested in A/B testing, where it would be like a nightly thing versus like a weekly thing and see if there are definite benefits. Right now, I'm just happy that they deployed it. And so it would, I think there's a lot of experimentation that can be done with that. They also wanted to start looking into doing it real time, which is its own beast because it's massive and requires intensive calculations that shouldn't be done real time. And so it'll be interesting to see kind of where they end up going with it, but it'll be cool.
Did you consider seasonality in any way in your
did. Yeah, no, that's a great one. Yeah, so I did. It pulls, I didn't put this in the slides, it pulls interactions with items within the last 60 days, and I think it's like 260 to 350 this time last year. So essentially it grabs what you looked at recently and what you looked at this time last year to go ahead and grab that seasonality in there. It does.
How do you go about handling cold start customers? So customers that you don't have any data on.
Right, yeah. So since we're in like our initial stages of rolling this out, those customers are just seeing the top selling pizza items right now. And so until we go ahead and grab that data, if we don't have data on them and don't have recommendations, they're just seeing our top sellers. But I think in future iterations, that's definitely something that we want to tackle, but just kind of getting it initially rolled out is our main goal here, and then yeah, going ahead and really digging into figuring out how to tackle that problem as well.
What are some of the costs implied with running the recommender system more constantly rather than monthly or yearly?
Right, so the biggest cost in this particular system is the data pod clusters, just because they are so massive. It just spits it up. I forget the exact parameters of it, but each one is like 100 gigs of RAM and stuff. They're pretty extensive to go ahead and fit all of that into memory. And so making that part as efficient as possible really reduced the costs. The other thing is that the way Google sets up their billing, BigQuery is actually a really big cost because it transacts every time you pull from that, and I'm pulling massive amounts of data from web interactions and purchase history and stuff. And so it's just, that can add up. I notice I like pay attention to the GCP graphs of like billing. And if I like run it more than one time in a day, it's like the BigQuery one is just like, it struggles. And so that's why we ended up, it was like a dual benefit. We got seasonality and we were pulling less data. If we did it that way, as some cost saving and measures there, figuring out how to really make Spark run as efficient as possible so that we could have those clusters spun up and then spun down as fast as we could was some really big ones. That's really all that we run into. And then I don't know that it was a cost, but a lot of performance testing with the cloud functions that is the API. So when it's go ahead and pulling that data, we did performance testing around that, and then haven't really seen a massive cost around that, but I could imagine it could be costly.
Question?
Yeah, so I'm curious about your similar item recommender. So what is the sort of metric for model accuracy there? How do you validate that work event is performing better than sort of tip by tip?
Right. I super scientifically looked at it. So there are certainly ways to go ahead and try and quantify that in different ways. This could be done with the naked item. It was pretty obvious that it was like grabbing and like really focusing on weird things in it, where when I ran it through word to vec, it was a very similar translation. And so if there was a big concern around it, then quantifying that I think would be worth it. But as it was not a concern of theirs, they didn't want me wasting a ton of time on it. And so if they were like, cool, I like printed out 50 examples and random examples, they're like, looks good. And so it was kind of a back and forth with the design team and the leadership team as to where our priorities were on that one.
Great, thanks.
If anybody has more questions, you can grab my after. I'll just leave it on.
Okay, next we have Diana Feo, who's talking about machine learning explainability. SHAP. I didn't know how to pronounce it. SHAP. Shape.
Hey everyone, I'm Diana, and I guess now you know what I'm talking about. So the last few years, there's been more and more conversations around algorithmic bias, the question of fairness in machine learning and AI, and those kinds of questions. And at the center of being able to determine if a machine learning model or an A model is fair, you need some notion of explainability to know, to be able to answer why is a prediction being made the way it is. So what is explainability? Until a while ago, whenever the reason people use more simple models like logistic regression or linear regression is because you have explainability out of the box. You know right away how each feature impacted the prediction that you're getting. And so what is explainability? It's the ability to take a model and be able to understand how much each feature contributed to the prediction that you're making. So in this example that we'll talk about for the rest of this very short 5-minute talk, we're predicting fraud and we have a data set of a bunch of transactions. And so let's say that we create a little boosted tree model, and a tree might look like you ask whether the total of the transaction is more than $1,000, and if it is, you ask if this person's a super big luxury shopper, and if they're not, then you might raise the probability that you're that this transaction is fraudulent. So these are the kinds of features that we're looking at. So in the past, people for explainability have used feature importance, which is available for a lot of models, especially tree-based models, not really for deep learning. The problem with feature importance is there's a couple drawbacks. First of all, it's a global view, so you might know that the transaction total has a big impact across your training data set, but for a particular transaction, maybe the fact that this person's a luxury shopper is really the big explanatory variable there, and so you don't get that local view. You don't get consistency or local accuracy with feature importance, which I'll talk about in a bit, and you also don't get directionality. So if you have a feature such as age, you don't know if higher age contributes positively to the likelihood or to your prediction, or negatively. So enter SHAP. It's a library, it's a Python library that does explainability across multiple models. So there's support for tree boosting and neural networks. The way that SHAP, so with SHAP is the algorithm, it stands for, or it's the package, it stands for Shapley Additive Explanations, and it computes Shapley values for each of your features. So what is a Shapley value? This comes from the 1950s from game theory, when Lloyd Shapley was working in game theory and he was trying to create a way to assign credit for cooperative games. So if you have 4 participants that are cooperating in a game and you're trying to figure out how to assign credit, like who contributed the most, who contributed the least, then how do you make those decisions? And the solution here, which was unique and had certain properties, was that you take all of the ways that you can permute the players with a participant, and then you look at all the ways without the participant, and then you subtract them. So you're kind of estimating how much each participant adds to how much you're getting the reward in the game. And so this translates directly into machine learning. And the way that I think we can think about it for trees is that what you do is you take a feature and you remove it from the model, and you calculate all the possible ways that you can make the prediction by permuting all the other features without that feature you care about, and then you add it back in. You can kind of calculate the difference, so it's contribution. The great thing is that these Shapley values are the unique way of creating feature attribution that's locally accurate and consistent, which are 2 very important properties that I'll try to explain quickly. So the local accuracy means that for a particular transaction, for example, the feature import, or the Shapley value, so the explanation for that feature adds up to your prediction. And you get consistency, which means that if you fix a bunch of features and don't move them, and you increase another feature, then the Shapley value or the explanation for that feature can't decrease. Okay, so what do these Shapley values look like? Here's an example of predicting hypoxemia, which is lack of oxygen in the blood during surgery. And you can see that in red are the features that are positive, increase your risk of your predictions, and the green features decrease your risk of your prediction. So for this particular data point, which is particular feature values, you can tell that the tidal volume increases the risk the most, and the pulse is decreasing your risk the least. So that's really cool. It means that for any of these tree boosting models, you now have, you can look inside the box and you have explanatory value. You can explain what your model is doing and interpret the model. SHAP also has like really cool stuff where you can see how maybe you can see interactions between features, and like you can do a lot. Okay, and then another nice thing is, since you're getting local explanations, is you can plot your entire training set, and each vertically is each training set here for this prediction of hypoxemia. And you can see that over time, the explanations may change depending on all of the feature values. So if we go back to fraud, what this might mean is that, let's say that there's like a 40-year-old person buying tons of Taylor Swift tickets all the time. Well, that might increase your likelihood of fraud. And so in that case, the high values are going to be age, and there might be the purchase price that might be under $1,000. Whereas for another transaction, someone that usually purchases $50 things suddenly buys a $2,000 item, and in that case, the transaction total is going to be the big feature that's explaining the prediction that you're making. So the great thing is that not only does this work for tree boosting and other models, but you can actually apply it for neural nets. So here's an example of a vision problem, and the red pixels are the ones that increase the probability of your class being, in this case, a do-witcher or a meerkat. And the blue is the ones that decrease the probability. So now for neural networks, they don't have to be exactly a black box. You can look inside and kind of figure out which pixels are helping you make the prediction. That's it, thank you.
It sounds like it might be computationally expensive. Is it take up a lot of resources to get all that stuff out?
Yeah, it's crazy expensive because in theory you're supposed to consider all the permutations of all the features, but SHAP does approximations of these, and they're pretty computationally efficient. Like you can run them on reasonable data sets. I've only started using it, and so I can't speak to that too much, but the whole point is to be able to run it, even though in theory computing these SHAP values is impossible.
I'm curious on that, the neural network. So applying it to the case of the neural networks, you remove one of the weights and see what the contribution is. So it is by individual weights in the network.
You'd be removing the pixels, and that's about all I know because I don't really know the very specifics of how they do the approximation in the case of neural nets. Anybody else? Thank you, Dan.
All right, for our third and final talk, something nice and light. Network analysis of political discourse on Twitter. Chris Kohler, thank you.
Hello, everyone. My name is Chris Kohler. I'm a recent graduate of CU Boulder of the Information Science Department, and this is actually a presentation on the capstone project that I worked on for my senior year. This is my portion of the project, which is a network analysis of political discourse on Twitter. Now, what I mean by that, and I'm just going to dive right into it, is this right here. This is essentially 450,000 tweets and retweets that I have mapped through Gephi into a essentially network analysis that has clustered them together based on how often these people retweet each other and retweet content similarly, which then clusters them into groups. So in this cluster, I'm not going to lie, I did not do anything special with Gephi in this. I used 4StatList2, which is the default network analysis algorithm to create this. I had no expectations, but I always hoped it would look exactly like this, and it does. It is exactly what I thought. The conservative cluster, the liberal cluster, and then the kind of strange outlier UK cluster. I'll get into a little bit more detail about that, but what I found so interesting about this is that it was so clear, the division. And what I've done is I use hashtags as a nice way to kind of gather specifically political information or political tweets and retweets. And so these are the hashtags that I've used. I used 12 of the most popular hashtags on Twitter, which surprisingly, there aren't a ton of popular political hashtags on Twitter. But the large majority of them coming in at MAGA, hashtag Trump, hashtag Democrats, hashtag resist. MAGA taking up the red in the graph that you see there. So the red and the colors are essentially the retweets. Each one of those is a connection, and the color represents which hashtag was used in this connection. So moving forward, I'm going to take a look at the conservative cluster. So what you see there is each one of those nodes is not a tweet, but a user, and that is their Twitter ID. And so I wanted to just kind of get a better idea of exactly what I was looking at. So I decided to explore our user bases in some of our larger nodes. So the first one we have here is @RealJamesWoods, who is a fairly famous right-wing actor. And this tweet is not the entire node, but it is one of his most popular of this data set. Right after him, we have Lou Dobbs, who is a conservative news pundit on Fox News, as well as Donald Trump himself, right there, who I was actually surprised to find that he's not as large of a node as I expected him to be, but I actually discovered that's because he doesn't tend to use hashtags in his own tweets. He tends to tweet entirely just himself. So I was interested and I did a little bit of digging, but I think, oh yeah, that was all I had for that cluster. So then I moved on to the liberal cluster, and there's a bit of a strange difference between them. Immediately you'll notice the most popular in the liberal cluster is Indictment Duck. I don't know if any of you have heard of Indictment Duck. I sure hadn't. And it kind of follows through that pattern, whereas the conservative cluster had really prominent users, the liberal cluster has very kind of common people. Admittedly, I should say that this data was collected from April 7th to April 21st of this year. So it is a bit dated, and obviously if I had more data, I'd expect to see larger liberals in this group. But moving on, it's just a lot of users that are just kind of seem to be situationally at this time highly retweeted. So then looking into our UK cluster, at this time, this is when they were protesting Donald Trump coming to the United Kingdom because they had invited him to potentially talk in Parliament, and this was somebody basically saying he's not allowed, it is an earned privilege. So that was my clusters. So I then wanted to explore, okay, we have two very distinct clusters. What about those accounts in the middle? Who are they? And honestly, the strongest ones, the largest ones, were actually fairly close to the conservative cluster. This is one of them. It is a profile called Alpha and Omega. It is actually pretty clearly a bot account. It has 236,000 tweets, and it only follows 3 people. And the reason why it is a large node is because of how often it retweets other people's content. Whereas most of the people in the conservative cluster are large because a lot of people retweet them, this one is large because it retweets a lot of others. And it kind of, the pattern continues. This one, it's politics polls, which is, in your opinion, is Donald Trump a honest and trustworthy president? Now, the interesting part here is you see that the response to this poll is 68% yes. That's actually confirmed in my network because it is much closer to the conservative cluster. When this question was posed, a lot more conservatives picked it up and talked about it, and so it kind of got that conservative bias in the answer. Moving forward, we have the just straightforward I retweet MAGA bot. Can't get any more straightforward than that. As well as this incredible profile, the Stop the Madness, and you can tell everything you need to know about this by the hashtags in its description. Stop abortion, stop gay marriage, stop illegal aliens, build the wall, secure the border, deport them all. You get it. This has 1.01 million tweets. It is pretty obviously a bot account that's been operating for a long time as well. So I wanted to analyze this. Why is this? Is the conservative cluster so much denser and has larger tentpole users? Are there more conservatives on Twitter? Probably not. Are conservatives more consistent with their use of hashtags? It seems possible, but I don't have enough data to confirm that, and that's not what my project was about. Conservatives and their tentpole users that they retweet more often, it does seem so, that they seem to cluster around these people. But again, my data is limited. And that brings me around to bots. I found a lot of bots, as I showed, that retweet conservative content primarily. And a study from the University of Southern California identified 2,700 Russian trolls, and they found 28,000 users retweeting their content. Of those, 892 were liberal and 27,000 were conservative. So maybe it's that conservatives share troll content 30 times more often than liberals, or maybe they're just better at retweeting and sharing content out. It's hard to say. So I think that it might be that conservatives retweet more. And I want to take a closer look at that. So breaking down, this right here is a graph of the ratio of how many tweets there are to retweets. Tweets being in blue, retweets being in red. The top 3 tweets by hour are MAGA, Trump, and Democrats, each one of them coming in at about 1,000 tweets an hour and more than double that in their retweets. They're all very popular conservative hashtags, and the kind of chart that I have over there is an illustration of how many retweets there are to every tweet. So like something like Republican, for every tweet, there's only about 0.8 retweets. But for something like Build the Wall, which I've noticed is actually very popularly picked up by bot accounts, there are 3.8 retweets to every single tweet. And this then also brings us to an interesting part that I discovered in this is the follow back resistance. It was a movement that I was not familiar with before I started in on this, but essentially it's a group of liberals that have FBR, hashtag FBR in their posts, hashtag FBR in their profiles. It's an indication that they're part of a resistance against Trump. And so if you see that, you're supposed to follow them back and retweet their content. And it shows that it's actually quite effective, since there are 3.6 retweets to every tweet. So this is more an exploration rather than a understanding, but I hope you enjoyed. Thank you.
Included around the board, do you have any trouble getting access to the data for the analysis?
A little bit, yes, actually. I was only given one API account for this, so I had to collect at a rate of about 100 tweets a minute. So collecting that data set, I'd actually collected one before and had discovered that the way I was collecting it had obscured the Twitter ID, so I had to start over again with a week left in my capstone. But it took about 4 days of my computer constantly running to collect all of that data. Yeah, and it was a trying effort, but it was definitely worth it. Yeah.
So in your graph, how does the number of hashtags per tweet affect its position as a graph? So it has 30 hashtags. Is it more centralized than it just has one?
Yeah, so what I discovered, well, the reason why I used that metric is that I found that the conservative cluster was really dense, and I kind of wanted to get an understanding of why it was so dense, and I discovered that's because they retweet, or whomever is retweeting them, a lot more than the liberals seem to be. And so I kind of wanted to understand why they were so dense, and yeah, exactly that.
It's okay, we don't have to be concentrated on the questions.
Were you able to correlate any of this around news articles that were coming out during this time frame that you were looking at the beginning to understand how that impacted different movements or other variables outside of it?
Yeah, absolutely. At the time I had taken this, actually, one of the hashtags in the group is hashtag Russiagate. And this was actually at the time before Mueller had gone and given his testimony. So I've noticed that that hashtag has completely disappeared, as well as the UK cluster. That was another node that was entirely based on the news of that day. So, admittedly, I only got 2 weeks worth of data, but 450,000 tweets inside of 2 weeks I thought was pretty incredible. And I could keep going, but my computer started to get pretty sluggish with what I was giving it already in the network. Thank you.
So what if somebody tweeted and in their hashtag they kind of feels like they support a Republican, but what they're saying is not necessarily supporting the Republican.
audience was that?
Right, actually, that's a really good question. In fact, it's actually kind of really nicely illustrated here. So in green is resist, and in red is MAGA. You can actually see there's a lot of green lines going over to the conservative cluster, and a lot of MAGA lines coming back over the liberal cluster. And that's because these people are actually retweeting these people to talk about how insane they are, or talk to their friends about like, oh, look at this person and what they had said. So I noticed that the crossover was there in retweets, but not in the conversation. They would retweet each other's content, but not necessarily participate in a discussion.
All right. Thank you. Get back to the. Those are our talks for this evening. We have an icebreaker so that we can keep talking amongst ourselves. Okay, so how do we make machine learning more intuitive? I guess aside from using chat. So thank you all for coming. If you need selfies with us, come on up. We have some more beers. Thanks a lot for coming.
Yeah, I'm gonna be up here just to get this all closed out. Of course. I'm gonna get some music back on here for a second, real quick. This Tribe Called Quest is always good to listen to. Oops. All right.
Perfect. All right. Thank you very much, sir.
Yeah. Okay. I'll walk by. I don't know how long
Hey man, how you doing?
Yeah.
What are you doing these days?
Go to the startup.
We're having fun.
You haven't heard of it.
Oh, really?
Yeah, no one's heard of it. It's a neighborhood sharing app. I really like it. So neighbors can share stuff, vacuum cleaners, small stuff.
Right on.
Salad bowls, really nice for date night.
Lawnmowers.
Yeah. Trying to like make it really good, like with finding some tools and cleaning. If you want to buy like a flower saw and like make a business out of it. So anyway, yeah. Started coding. Like whatever 10 years after my Coco is. Yeah, I've had a few, but I was just thinking about 10 years ago. Sean Oshman. Yeah. How are you? Great, man.
I'm working at a company here in town. I was in Denver for a while. So I'm loving not having to go to Denver today. Great. In South Florida still. Yeah, that's good.
Great. Yeah. You're part of this new finance thing. And, sorry, I forgot the thing here.
No, I just switched my career to product management. So, yeah, I'm doing that. We're a cybersecurity startup, basically.
Right, yeah.
See where it goes. Dude, like six big raggy people now. So, it's a lot of fun.
Wow.
It's intense, but it's good.
Awesome.
Good, that's good.
Thank you so
I went back to
much.
grad school, got a degree in analytics. Second one, first 5 years. I don't know. I have no idea. Yeah, like the guy who originally coming here from, he was one of my professional staff. And then there's another guy that sent this dude too. I got the extra credit requirements. Come here, ask questions. Most of them don't.
Yeah. Get some lightning rounds. Yeah.
So,
Really keeping up.
it's pretty easy. Yeah, it's good. I'm actually going to be leaving this just because I got to focus on work and keeping downtime. So I'm going to do that in the coming months. I might come back to you guys. I'll still be involved with you guys offline. I just won't be able to take data.
Yeah. Yeah.
That's good.
The company's doing well then. Like,
Oh yeah.
70 employees.
Yeah. Yeah.
Yeah. Okay.
Yeah, I started there in April. It started up in 2015 or 16. A couple of years of just being, and then at election point, now where we're at. Now we're pretty cool. Pretty cool. Definitely learn a lot.
Yeah. That's really in the weeds. Cybersecurity.
It is, yeah. It's an interesting challenge. We have too much data. We aren't leveraging it the right way yet. It could be really cool how it changes.
I realized the one thing I forgot to say in the opening slides was that you're looking for speakers. I didn't get that.
That's all right.
I'll see where all that goes.
Yeah.
It's a good job right
I'm
now.
on Twitter too.
Could be staying good job can become somehow better. I'm not sure how. So I guess I call it a great job right now.
A lot of people, but a lot of them forget to go.
Bumps in the road and have to make it harder.
I feel like I don't know. I mean, I feel like it's.
Yeah.
I didn't. I tried to be in Denver. Texas.
Yeah. I would hope that some of them
Something
might be
more
Yeah, I know.
businessy.
That's what I was asking.
No, it's for the product could be a lot slower.
We know that there are.
This is like we need to really not talk about slide that slide something out 3 months later. I never use slides for I want to work somewhere.
I know they have assignments and everything, but they'll always.
Yeah, internally.
Yeah.
Yeah.
Conversation. We're not that on the page. Something else is wrong. So,
Yeah, well, maybe we'll put something in the text.
Definitely how I've evolved. Yeah, I've had a few different companies where it's like 2 months later, we're still kind of discussing and ruminating on like, put it out there, like, figure it out, you know. Every morning you're like, maybe.
I kept reading it as tape when I was reading.
With what we're doing is very challenging. The reason that no
That seems pretty interesting.
here is that hard. People on it start to become much easier. The only way to do that is to know, is this feature right?
It's different. I mean,
You can do a little prep in the beginning. You can ask some customers, they have no customers, just send it out.
But it's also not quite so obvious. Some words that
Once you do that, you're going to get so much good input.
it's only been a few days, but so far it's not
Yeah.
bad.
Yeah. It's good to hear. I'm sort of at that position, just on a very micro level, just like with the neighbors.
Hi, Steve Rose.
Very much like, here's an idea,
Absolutely,
here's
hope you
a
enjoy.
feature, this works for you, statistics that you need care, feedback. And like every, usually like the morning, the evening, oh, I didn't expect that.
Oh, okay.
So is it your deal or is it like somebody else started it? Or?
No, it's mine. It really is the evolution of the Coco. It's this concept of like a community thing that is not like, it's not a charity grab or a charity case in itself. Like I was always trying to run the Coco as like a for-profit entity. Didn't work like ever. Like, you know, nowadays it's yeah, it's just like a share app, like Uber for everything. You know, it's like that micro level. It's just really the concept of getting to know your neighbor. I find really exciting. It's like, do you like your neighbor? Do you care? Do you want to make money off them? Do you want convenience? And it's just like a social, technical kind of challenge. So, yeah, maybe it's like,
I'm listening. I just got to
yeah, like psychologically similar to your thing as far as like how fast-paced and how innovative, and you just have to accept change, accept discomfort.